In this example, we will conduct a hypothesis test to test a claim about a population mean. And in this case, we will assume the population standard deviation sigma is known. So in this example, according to a vendor, a 50-cent vending machine is supposed to dispense 14 grams of chocolate. A customer suspects the machine has been dispensing less chocolate lately, so he purchases chocolate at 31 randomly selected times and records the weight of the chocolate dispensed at each time. He then calculates the mean of the 31 weights, okay, and finds it to be 13 and 69 hundredths of a gram. Assume that the population standard deviation is known to be sigma equal to 907 thousandths of a gram. Use a hypothesis test to test the claim that the mean amount of chocolate dispensed by the machine has decreased. So the first thing I'm going to do is state the null and the alternative hypotheses. So let's just read the question carefully again, or at least the part where we're asked to test a claim. So use a hypothesis test to test the claim that the mean amount of chocolate dispensed by the machine has decreased. So I want to be clear here that when I use the notation mu, that this mu is equal to, it's a mean, it's a population mean, and it is the mean amount of chocolate dispensed by the machine. Okay. And remember that our null hypothesis is just the hypothesis that nothing is going on. Things are still the same. There hasn't been any changes, status quo. And in this case, that would be the idea that, the amount of chocolate being dispensed by the machine is still 14 grams, right? It hasn't changed or decreased. Nothing to be worried about. So in this case, we would say mu is equal to 14 grams. So still equal to 14 grams. Now, the alternative hypothesis we see in the claim is that the mean amount of chocolate dispensed has decreased. So the vendor is actually giving us less chocolate. So something changed, something happened. This is like sort of a challenge to the null hypothesis. And so this would be written as the population mean of the chocolates dispensed is less than 14 grams. So I also want to point out that if you look at the alternative hypothesis, which is this guy, and you see that we have a less than symbol here, some people will say that this is a left-tailed test. And remembering this can be helpful in computing the p-value, which is a probability we will compute later. We will be finding the area of a region that looks like a left tail. In the second step of the hypothesis test, we usually will check any requirements that need to be checked before we can use the formulas and in this module. And this is usually the step where you would gather your sample data and collect your data and summarize your data, but that has already been done for us. So we'll just be checking requirements and calculating the test statistic. So since in this example we are conducting a hypothesis test to test a claim about a population mean, we want to check first and foremost that we have a random sample, which in this case we do. We also have that the sample size is 31, and that's greater than 30. So the central limit theorem tells us that the distribution of sample means will be approximately normal. And we also have that sigma is known. And we have sigma is 0.907 grams. So the requirements are met. The next thing I'm going to do is I'm going to calculate the test statistic. And just so you have a sense of what we're doing when we calculate the test statistic, I'm just going to draw a little picture. So this picture represents the distribution of sample means of size, in this case we said size 31, so let this be the sampling distribution of X bar for samples of size 31. So of course, I'm assuming that if I assume that the null hypothesis is true, then the mean of this distribution is just the 14 grams, which is just our null value. So what the question we're asking when we calculate the test statistic is we're asking, so if I get a sample of size 31 and and the mean weight is 13.69 grams, how far away is this from the mean in my sampling distribution? So how far away is this from the null value? How far away is the sample value from the null value? And the best way to see this is we would just calculate the z-scores, the corresponding z-scores here. Of course, the z-score of the mean is 0. So what we're really looking for with the test statistic is we're looking for the z-score of our sample mean, okay, in the null distribution. So that is the sampling distribution where we assume that the population mean really is 14 grams. So the test statistic is calculated as follows. So this is just our sample mean. We're using the null value, 14 grams, as our, and then we have our known standard deviation. So I'm just going to fill in these values. Sample data minus null value divided by population standard deviation, and our sample size was 31. So I would pop this whole thing into my calculator, and I would not want to round anything. This is the value I get. Okay, so since it's a z-score, I am going to be rounding to 2 decimal places. And I will be using table, the normal standard normal table. So this is the z-score I get. So this is basically telling me that this value, our sample data, sample mean was 13.69 grams. That is about almost 2 standard deviations below the mean. So in the null distribution, the null value of 14 grams is almost 2 standard deviations away from our sample data. So let's move on to step 3. In this step, what we want to do is we want to calculate the p-value. Okay, and just to remind you, the p-value is just this area. Since this is a left-tailed test, it's just going to be the area to the left of our test statistic. And so in this case, how do we calculate the p-value? Since it's a left-tailed test, in other words, since the alternative hypothesis had a less than, the p-value is going to be given by the probability of getting a z-score that is less than negative 1.90. And if I use the standard normal table, this is 0.0287, so about 2.87%. Let's take a minute to make sure we understand what the p-value means. So first of all, we said the p-value corresponds to this area in this left tail. It's the area to the left of negative 1.90. And so what does this 287 10,000ths mean? Well, it means that if H naught were true, okay, if we assume that that is true and that the mean amount of chocolate dispensed really is 14 grams, then there is a 2.87% chance, which is fairly low, of getting sample data like those that we observed, meaning a sample having size 31 and a sample mean of 13.69 grams of chocolate. Okay, so there's only really a 2.8% chance of getting sample data like that. And to be even more specific, what I mean by like is I mean as low as 13.69 grams or lower. Okay. So that's how we can interpret the p-value. So our final step, step 4, is to draw our conclusions. And the first thing you will always do is compare your p-value, which in this case was 0.0287. We're going to compare that to our significance level, which was given as 5/100ths. So that's alpha, the significance level. And you can see in this case that the p-value is less than the significance level alpha. And that tells us we are going to reject H naught. So, and if I state that in context, this means that there is sufficient evidence to support the claim that the amount of chocolate dispensed has decreased. Okay, and so all this is saying is, look, there's like a really low probability, like a 2.8% chance, which is below our 5% threshold that we set. There's like a really low chance that we could have gotten this sample with a mean of 13.69 grams for 31 different times that the chocolate was dispensed. This could, the chance that this would happen if the population mean was really 14 grams, that the chance is really low. So we reject the H naught. We don't think that this is true.